Welcome to MRL. In this learning session, we'll learn the solutions of examples of exercise 2.3 of Polynomials chapter 9th NCERT Ganita Manjari textbook. Now, the first example given here is the amount in savings account of an individual is rupees 500. The monthly pocket money is rupees 150. We have to find the money she has at the end of every month from the second month onwards to form a linear expression for amount for n months. So we have this example in two parts. So let us go with the first part. Now, for the first month, she has an amount of 500 rupees in the account, and there is 500 rupees, amount is 500 rupees. And in the second month, an additional amount of 150 rupees she receives as a pocket money, and therefore the amount would be 500 plus 150, 650. In the third month, 650 plus 300 is 800, because 150 plus 150 for 2 months will be 300, and therefore it is 800 rupees. And for the nth month, it will be 500 plus 150 in the bracket n minus 1. So therefore the linear expression for the amount for the nth month is an is equal to 500 plus 150 into bracket n minus 1. Now let us verify whether this linear expression is true or not. The first month n becomes 1, 1 minus 1 is 0, therefore it is 500 rupees. Second month it is 2 minus 1, 2 minus 1 is 1, 1 into 150, 500 plus 150 is 650. And for third month it is 3 minus 1 is 2, 150 into 2 is 300, 300 plus 500 is 800, and 100% the linear expression 500 plus 150 in the bracket n minus 1 is a correct linear expression for amount for n months for the given example. So please remember that. Now coming to the next example, there are 120 members in a rally at the start. 9 members drop out each hour. Please understand this. There are 120 members in the beginning or the start, and 9 members drop out each hour. Now to find the members that remain after 1 hour, 2 hours, 3 hours and so on, and also to find a linear expression to find the remaining members in the nth hour. So let us understand this. The 0 hour, the total members are 120. In the first hour, 9 leave, therefore 111. In the second hour, 18 leave, therefore the number of members is 102. In the third hour, 27 leave, and therefore the total number of members remaining are 93. And in the nth hour, it will be 120 minus 9n. Therefore the linear expression is mn is equal to 120 minus 9n. So let us understand, verify this. If n is 0, 9n is 0, therefore it is 120. If n is 1, it is 120 minus 9, that is 111. If n is 2, then it is 9 into 2 is 18, 120 minus 18 is 102, and therefore the linear expression m of n is equal to 120 minus 9n is 100% a linear expression of the given example. Now the third example, we are given the length of a rectangle. Of course, length of a rectangle is 13 centimeters here, and the breadth is 12 centimeters. Length is 13, breadth is 12, and we have to find the area, and area is 12 into 13, because the area of a rectangle is L into B, therefore it is 156 centimeters square. Now length remains the same, the breadth increases by decreases, not increases, decreases by 2 centimeters. The breadth has become 10 centimeters, the area decreases, has become 130 centimeters square, and when the breadth is 8 centimeter, the area is 104 centimeters square. Now we have to generalize this. The general formula would be for a breadth of B, the area A of B is equal to 13B is the general linear expression, and you find that the breadth decreases by 2 centimeters, therefore it's a linear decay, and so also the area decreases uniformly with having the same the consecutive terms having the same difference, and therefore that is also a linear decay. So the difference between the consecutive terms is a constant, therefore it's a linear pattern, and the general form is A of B is equal to 13B. So please remember that. Now coming to the next example, we are given length as 7 centimeters in all, breadth as 11 centimeters in all. The height changes, the height is 5, 9, 13, that means there is a increase in height. Now we have to find the volume. We know that the volume of a cuboid is L into B into H, therefore when I multiply L into B into H, I get 385 centimeter cube for the first one. When the height is 9 centimeters, the volume is 693 centimeter cube, and when the height is 13 centimeters, the volume is 1001 centimeter cube. And if you have to generalize this, then the volume for a given height h is equal to 7 into 11 into h, or 77h. So the volume is 77h. So if h is 5, the volume is 385, h is 9, the volume is 693, and so on. So the height and the volume have a linear growth. and the height and the volumes. Height increases, so also volume increases. There's a linear growth. The represent a linear pattern as the consecutive value have a constant difference, and the linear expression is VH is equal to V of H is equal to 77H, and that is a correct relation. Now coming to the next example, there is a book of 500 pages. A person reads 20 pages every day. Pages read every day is 20 pages. Now the number of pages left unread after 15 days we have to find, and also we have to express a linear pattern. So let us understand this. On 0 day the number of pages are 500. On the first day 20 pages are read, the remaining are 480 pages. Second day 20 and again 20 pages are read, therefore the remaining would be 40 pages less, that is 460. Again 80 pages less, 440. Again there is a less 15 to 20, that is the 300, that means the 200 pages, that is 15 days. After 15 days the number of pages remaining are 200 pages. That means the general form is 500 minus 20n. So please understand this. Up to third it is 440, that means third day, but 15 days means I have to multiply 20 into 15, that is 300. 500 minus 300 becomes 200. So 200 pages are left on 15th day. Now for n days it will be 500 minus 20n. So now that is what is a linear pattern. Very clearly it's a linear pattern because the consecutive terms have a constant difference. Now the pages left after 15 days, as I have already told you, 500 minus 20 into 15, that is 200 pages, and the linear expression is 500 minus 20n, and it is correct. So please remember that. Okay. Now for example, if you want to verify it, if we put n as 1 here, it becomes 20. 500 minus 20, that is 480. If I put n as 2, it is 40, therefore minus 40 becomes 460, and so on. So therefore it's a correct relation of a linear pattern. Now coming to the next exercise set 2.4 of polynomials of 9th CBSE Ganita Manjari textbook. Now in this, the first example is the height of the plant is given as 1.75 feet, that is the initial height, and each month the plant grows by 0.5 feet. Now what is the height after 7 months? That means height after 7 months will be definitely the initial height plus 7 times the increase in height, therefore 1.75 plus 3.5 becomes 5.25 feet. Now we have to write a table of showing the increase in the height for 10 months, and that's what I've shown here. So for 0 month it is 1.75 feet. In the first month it will be 1.75 plus 0.5 feet, 2.25 feet. In the second month again there will be an increase of 0.5, that means there will be 1 feet increase, 2.75 feet is the new height, and in the third month the total increase in height is 1.5, therefore the total increase will be 3.25 feet, and so on. You find that the 0.5 feet increases linearly here. There is a linear growth in height, and also the total height is also, there is a linear growth. So the increase in height is a linear pattern, and as the month increases the height also increases by a fixed amount, therefore it represents a linear growth. And the expression that relates the height and the time, that is the period, is h of t is equal to 1.75 plus 0.5 t. So please remember that. Now coming to the next example, the cost of mobile is rupees 10,000. The initial cost is 10,000, or the purchasing cost of the mobile is 10,000. Now it undergoes a depreciation, therefore the value decreases every year by rupees 800. Now what is the value of the phone after 3 years? Definitely after 3 years it is 10,000 minus 800 into 3 years, that will be 10,000 minus 2,400, that is 7,600 rupees. Therefore the value of the mobile will be 7,600 rupees after 3 years. Now we have to make a table of the time period of years, and also the depreciation of the mobile. In the first year it is 10,000. In the first year, means when it is purchased, it is 10,000. After 1 year it is 10,000 minus 800 is 9,200. So every year 800 is less, therefore the second year 1600 is less, 8,400, again 2,400 is less in the third month, 7,600, and so on up to 8 months. We find the value of the mobile would become 3,600 by the decrease of 800 rupees every year for 8 years. Okay. Now the value of phone depreciates with time, and it is a linear decay. Definitely it is a linear decay. Now the expression that relates the value of the mobile and the time period is v of t is equal to 10,000 minus 800 t. So if you use this relation, definitely the value what we have got in the table is correct. Every year there is a constant decrease in value of phone, and therefore it is 100% a linear decay. Remember that. Now coming to the next example, the initial population of a village is 750. Number of people moving to the village from the city every year is 50. So every year 50 people join, 750. So 750 plus 50 in the first year, 750 plus 100 in the second year, and so on. So the population of the village after 6 years would be 750 plus 15 to 6, 750 plus 300, that is 1050. Now we have to prepare a table of the years and the population increase of that village, and therefore I have made a table of 10 years here, and the increase of 50 every year becomes 1250 in 10 years. So table is very clearly self-explanatory here, so you can just follow that. The value of population increased by 50 every year, therefore it is a linear growth. Definitely there is a linear growth here. The expression that relates the population and time is P of t is equal to 750 plus 50t, which is a linear expression, and it's a correct expression because when I put t is equal to 0 here, 750 is the answer. When I put t as 1 here, the answer will be 750 plus 50, that is 800, and so on. Therefore the expression is 100% a correct expression. So please remember that. Now coming to the next very important example, we have a recharge amount for a phone is of rupees 600 initially. Amount reduced each day is rupees 15. So initial recharge amount is 600. Every day 15 rupees get reduced from it, and an expression for remaining balance after x days has to be found out. That is, the linear expression has to be established, and also the expression for remaining balance b of x. Okay, let us understand this. Now the remaining balance, if it is b of x, then it is 600 minus 15x every day. That means x is 1 day, that means 15 is less 2 days, again 30 is less, and so on. Amount reduced by rupee 15 each day. The remaining balance also decreases linearly, therefore it represents a linear decay. Now to find the number of days when balance is 0. So when the balance is 0, but natural bx will be equal to 0, bx is equal to 0, therefore 600 minus 15x is equal to 0, 15x is equal to 600 by 15, 15x is equal to 600, x is equal to 600 by 15, and that will be 40. Therefore the balance becomes 0 after 40 days. And also we have been asked to make a table for 10 days. So time is for 10 days here. The decrease is of 15 every month, and therefore it starts with the first day. The first day 15 rupees less, 585, and so on it continues, and for the 10th day the remaining balance will be 450 rupees, and this can be found out even by applying the linear pattern here or the linear expression here. Okay, remember that. Now coming to the next important that is exercise number set 2.5 again of the polynomials chapter of 9th CBSE textbook, that is Ganita Manjari. So let us understand the first example here. Now there is the modules are being accessed by an individual, and the modules accessed will have a fixed charge and an additional charge. So if 10 modules are accessed, the bill is rupees 400. If 14 modules are accessed, then bill is rupees 500. The total bill is 500 rupees. If x modules are accessed, then the bill is y. That means x and y have a linear relationship, and we can express this linear relationship by linear equation y is equal to ax plus b. Now the question in this is, the question asked here is to find the values of a and b. We have to establish the linear relationship between x and y and find the values of a and b. Now to find the values of a and b, there are two unknowns. We require two equations, and therefore we have got two informations here. Now when y is 400 rupees, then then x is 10. So we have got 10a plus b here, and when y is 500, then x is 14, and therefore we have got 14a plus b. Now we can solve these two equations by any one of the methods of solving equations. So I have gone by elimination method. That means 10a plus b is equal to 400, 14a plus b is equal to 500. Subtracting the 2 from 1, we get 10 minus 14a plus b minus b cancels here, 400 minus 500, so minus 4a minus 500, a is equal to 100 by 4, a is equal to 25. Now put the value of a 25 in one of the equations, then we get y is equal to, that is a is equal to 25 in one equation, that is 10a plus b is equal to 400. So 10 into 25 plus b is equal to 400, we get b is equal to 150. Therefore the value of a is 25 and b is 150. Try to understand this method, and it's simple, but you have to understand the method and solve it. Okay, now going to the next example. Now we have a badminton court and a person uses it, and for using the badminton court he has to pay a fixed charge and an additional charge. For 10 hours he has to pay a bill of rupees 800. For 15 hours the bill paid is 1100 rupees. Now if the court is used for x hours, then the bill paid is y rupees. Therefore there is a linear relationship between x and y, and the linear relationship is y is equal to x plus b. Now we have to find out a and b. Now what we do is, let us take y is equal to x plus b. When y is 800, then x is 10, therefore 10a plus b. When y is 1100, then x is 15, and therefore 15a plus b. Now solving these two equations, we get 15a plus b is equal to 1100, 10a plus b is equal to 800. Subtracting, we get 5a is equal to 300, a is equal to 300 by 5, and a is equal to 60. Putting the value of a is equal to 60 in one equation, we get 10a plus b is equal to 800, 10 into 60 plus b is equal to 800, and b is equal to 200. Therefore a is equal to 60 and b is equal to 200 is what are the values of a and b of the example. So please follow that. Now coming to the next example, we are given a relationship between temperature scales, that is degrees Celsius and degrees Fahrenheit. That is degree Celsius is equal to 8 degrees Fahrenheit plus b. This is the relationship given to us. Now we know that the ice melts at 0 degrees Celsius and the 0 degrees Celsius and 32 degrees Fahrenheit. If the temperature is measured in degrees Celsius, then it's 0 degrees, and in Fahrenheit is 32 degrees Fahrenheit. So also the water boils at 100 degrees Celsius and also it boils at 212 degrees Fahrenheit. So two different temperature scales are given here. Now we have to use a linear relationship that is given to us and find out the values of a and b. Now we have the linear relationship, that is degree Celsius is equal to 8 degrees F plus b, and if the temperature is 0 degrees Celsius, then it is 32a because it is 32 degrees F here, and plus b. And if it is 100 degrees Celsius, then it is 212a plus b. We have got two equations, 1 and 2. Solving 1 and 2, we go for finding out the value of a, and the value of a is 5 by 9. Very simple calculations, you can understand that. Now put a is equal to 5 by 9 in one of the equations, then 32a plus b is equal to 0. 32 into 5 by 9 is plus b equal to 0, therefore b is equal to minus 32 into 5 by 9. Now a is equal to 5 by 9 and b is equal to minus 32 into 5 by 9. Now putting these values in the linear equation, we get 5 by 9 degrees F plus minus 32 into 5 by 9, or degree Celsius is equal to 5 by 9 degrees F minus 32. A very important relation for finding out the degree Celsius when degrees Fahrenheit is given to us. So finding out the values of a and b, we have established a formula to find out degree Celsius or degrees Fahrenheit whichever the value is given to us. So please remember the method of establishing the relationship, establishing the linear pattern, and how the values of a and b can be found out by simple calculations. So understand each one of these examples. We have discussed 3 exercises in this video. So each exercise is different from the other. Understand the basics. Basics are same. Apply those basics. Learn the polynomial basics and learn how to solve these examples. Okay, note down in a book again for your reference. Okay, thank you.